Right, let's get started. So, welcome everyone. Today I'm here with Hubert. We are at our Warsaw offices and we are presenting to you our work on this past year at Falck on building egg. We will talk more about what it is and about how we tried to streamline our data engineering workflows. So let's start, of course, with an introduction. So, Hubert, you want to go first?
Yeah, hi. My name is Hubert. I've been working as a data engineer for almost 5 years now. I studied computer science and information management. Python was always a main language in all the projects that I've been working with.
Thanks. And I'm Pedro Rodrigues. I'm from Portugal. I'm working in the Copenhagen offices of Falck. I've been at Falck for almost 2 years now, and I'm working as a tech lead on helping to lead our data engineering teams on the healthcare business. For me, Python has always been the main language since around 2018. Anytime we work with data or we need to do some automation, it's just been the go-to tool. So it's a pleasure to be here today. So nice to meet you all in the audience. So this is what we'll be talking about today. We'll start with a brief introduction. Then we'll talk a little bit about our context at Falck around our data journey. We'll talk a bit about what is egg. So what is this thing that we have built? What was our technical architecture, designs and principles? Then we'll talk about how we distribute it to all the teams, the role of DevOps. We'll do a few live demos. And lastly, we'll end with some results, some challenges and reflections after 1 year of us working in this project. So without further ado, so everything starts from egg. So for those of you who are not familiar, there's always this old story, what comes first, the egg or the chicken? And for us, it's the egg. So our head of data engineering inspired us to call our project egg, as it comes from the mythology of the cosmic egg or the world egg, meaning that every time we have a new project, a new repository, we want it to be the foundation of new projects and of the future of data workloads at Falck. And about the team, so in total we have been about 11 people contributing to the project, and it's also been part of our global data engineering framework initiative. So in total, we've had 4 contributors from Denmark and about 7 from Poland. And to give some context, so now we've been working on it for about a year. The idea started end of last year, and we started already with the first prototypes around January. And as you can see, we've picked it up since and have been doing regular updates, building new modules. And here we are today in December. And it's a time also for reflection, but also to share a little bit of what we've done and looking forward to the next year on what we will be focusing on. So before we move on, allow me to also provide a few context and talk a little bit about the history of data at Falck and the need for scalability. So first of all, the data demand has been growing a lot at the Falck business. So it's quite clear, data is a core part of any business going forward. Of course, this is 2024, and Falck business and owners have recognized this, and there's been a huge investment into the business to help transition into digital future. And of course, that means data engineering has a crucial role to help make this happen. So our responsibility is to make sure we are able to capture the value from data. Also, recently, we have transitioned outside of the main Falck business. We are now a separate company entity called Falck Digital Technology. that also means we have been on this journey for a few years now, and we are now maturing outside of the main business. So if you look here at the chart, for example, our team has been growing from for over 25 people at this point in 2024. And all these 25 people are now spread across 8 different business teams. So each of them tackling its own business challenges. And let's talk a bit about tech stack. So of course, Python is at the core of our workloads. When it comes to big data transformations, we work a lot on Databricks, and then of course we use PySpark there. So it's a really great tool to help us with the transformation and the computing part. When it comes to cloud, we work a lot on Azure as our main tech stack. And so as you can see here in this diagram, these are a little bit of the technologies we mostly focus on. And we do build solutions end to end. So if you look from the left to the right, we have a role in bringing data from the raw source systems out there all across the business, all across the world. We ingest it into our data lakehouse, and from there we do a lot of work to clean it, to model it to something that is valuable. And then on the right-hand side, you can see we build a lot of data products around it. It can be as simple as a Excel table that can connect to one of our data systems, or it can be a Power BI complex data model. So it can also be a Power App, or maybe even a complete full stack app using some of our data. So moving on to scalability, and also to give a few backgrounds. So let's travel back to 2018. Back then, a lot of the workloads happening at Falck were very traditional business intelligence or BI type of work. So that meant, first of all, everything was a little bit more on-premise. We weren't so much on the cloud. There were a lot of SQL work, a lot of SQL warehouses type of work. And that was most of the projects out back then. And somewhere between 2018 and 2020, the team started to work a bit more on cloud and transitioning to cloud. And that's where Databricks came in, first of all, in around 2020. And actually, Falck was one of the first companies around Denmark area to start working with Databricks as its main tech stack on cloud for data engineering. And at the time, this was a really, really great change. So to help enhance the scalability, help mature the business, and simplifying and modernizing our tech stack. If you're familiar with SSIS jobs, that's sort of SQL agents, it was a really good upgrade to modernize. And here is a little bit of context of what it was like in those times. So in the beginning of Databricks at Falck, it's a lot of work that's centered around notebooks. So you can see in the first point here, a lot of things is based on notebooks, and then we use these magic commands to, for example, call notebook from within a notebook. And that is basically the way to do some imports or to reference other libraries of code. And we ended up having this, what we call these common libs and code libraries with reusable functions, data lake utilities, all kinds of things that are reusable. So that was a little bit of the start of building this code base of data engineering. And now, if we go back to where we are today in 2024, we are still on Databricks, and we are very happy about it. And now our team has also been growing a lot. And we're now at a process where we also want to try to mature and improve on our software engineering best practices. We want to now take the next step and take our code bases, take our solutions even to the next step. So we want to make them more efficient, easier to maintain, and more reliable from all kinds of aspects. And this is a little bit where also Egg will play a role, and what we are trying to achieve. So let me give you an example. So as you saw before, a lot of code was using these magic commands. We want to make sure we can instead use more imports. First of all, use more Pythonic modular approach of ways of working. That also means we want to use egg as a way to replace also some of these common libraries that I've mentioned before. So for example, there are some very common patterns or functions. For example, writing a table to a data lake, something very simple. We want to have this out of the box and very easy for engineers to find, that they don't need to copy paste it. So for example, egg here would be a way to replace it from the common lib. Additionally, number 2 here, also very important, we want to continue learning, continue improving our ways of working, trying to incentivize our teams, encourage the engineers to work more on local modules, focus on modularity, efficiency, and more IDE friendly. So this is what we call the journey from magic to modular. And like I was saying, so imagine you have this function write to data lake. So on the left, this is the good old copy paste. We've all done it, and now and then it's nice. It solves your problem. You need this function, and someone else already built it. So of course you're going to copy paste it and reuse the function, right? But as we grow and grow, more projects, more people, more teams, we then need to start to be a bit more mature, right? So thanks to our DevOps team, we actually started using what we call a project repository template. And using DevOps pipelines, we can automate the creation of new repositories. And with that, these repositories will already come with some predefined libraries, predefined functions in it. So we can at least here avoid some of the copy paste. And now with egg, we want to continue evolving and maturing on this good work. And basically the idea is we still use this template repository for new projects. But the idea now is we want egg as a Python library that anyone can install. And in fact, it's already installed in all of the Databricks clusters automatically. So everyone in the data engineering team, out of the box, goes to their Databricks cluster and will have it installed. And then, of course, there are different versions, different updates, but all of the code base for all data engineers will already have egg out of the box. And so in summary, if we look at our data strategy for 2027 and the core goals we are trying to achieve with this project of global engineering frameworks is, of course, first of all, scalability. We need to adapt to our team's growth and improve. Maintainability and quality. So as we grow, it's also very important we standardize and we make sure our code is more readable, it's more tested, documented. We also want to mature and innovate. So that means also engage a community of engineers to come together, to collaborate, to experiment, to brainstorm, and continuously work together and improve. And at the end of the day, that also creates a community for learning, for sharing knowledge, for engaging in conversations, and at the end of the day, help all of us improve and upskill ourselves to start using more and more best practices. So over to you, Hubert, to talk a little bit about what is egg.
Yeah, so to give you just a little bit more context of what is egg, let's think about what we are trying to do here. We are building a data pipelines, and a typical data pipeline will consist of these steps. You pull the raw data from the source, you have to parse it, clean it, transform it, you create curated tables. Out of this, you create data models. So on top of that, you also want to have some monitoring, orchestration, or validation. And the case is that we don't want to every engineer create their own orchestration framework or validation framework. Instead, we want to standardize these processes and unify this as much as we can. So to this, we create reusable components, reusable tools from which you can build your projects. So this will allow you to build your projects more quickly, and also people can focus on solving the business problems and they don't have to think about the technicalities. We have teams in different geographical locations. The business is very different in every location, in every team. The business needs are different. However, the core engineering problems would be similar. We still do most likely the same things. This is why we can standardize this and reuse the code. As an as an example, you can think about connecting services with each other. We store our data in Azure Data Lake. We use Databricks as our main compute engine, and even this task can be completed in different ways. If you want to read the data from storage account inside Databricks, you can do it in 5 different ways. New engineers don't have to think about this. There is a method, there is a standard way to do it, and this is what we want to achieve with Egg. Also, we will have some more external applications like Power BI or SharePoint, and we also want to have an interface to operate, to talk with these services with Python. Egg is just a Python wheel, so there is a repository with Python code. However, this is only a part of what we do as our global data engineering framework. So we use this opportunity to also improve our coding standards and maturity. In Egg, we try to write better code than we did in the past. Also, we try to standardize processes like creating a data models. For example, creating fact tables and dimension in a star schema model. All of that we want to support in Egg out of the box.
Thanks, Hubert. And let's talk now a little about architecture and the design of the framework, the Python library. So going back to this diagram, first of all, a lot of it happened, I would say, a bit organically and naturally. So for example, in the first few updates, back in January, February, the first code there was, for example, egg utilities or egg.utils. Also the data lake part, egg.adls. And it just happened very natural. So all of the modules we end up having today, when you look back, are sort of just a natural clustering of our processes into these different types on our ecosystem. So this here represents also really well what our Databricks environment looks like today. So for example, the data lake connection is already there, also out of the box. We already have Delta Lake there installed as also another framework we use for the Delta Lake house. Unity Catalogs is there also. It's a nice feature we use for governance and access management. And at the end of the day, all of this is also only possible because of our strong DevOps foundation in Falck. So for example, everything here is generated as infrastructure as code with Terraform. When a new team starts in a new country, they need a data lake, they need some Databricks workspaces. All of that is done in the same way using infrastructure as a code. And so that also means we can easily take Egg and plug Egg on top of that to help unify and engage on all this standardizing of these ways of working. So that is the key message here. And if we move on to principles, I would first of all say that when we started, I think it's the first project like this of making a Python library that we've tried to do here at Falck in Python. So a lot of these principles we looked back today, we didn't know them back then. So it's also stuff we learned along the way, and we adapted, we adjusted, and today I think they've been keys to where we are today and for us to continue forward. So let's start. So the first one, single responsibility. You might recognize this from the solid because that is where it comes from, but it's a very important one where every time we design some component, some function, we try to always ask ourselves, what is the responsibility of this function? Is it doing more than one thing? If yes, then we try to break it down into two. And that doesn't mean we don't also generate some more complex functions, but we try to keep things separate. Secondly, open-close principle. Again, this also comes from the solid principles. And of course, when making a framework, that means people will start using it in production. And that means we have a responsibility to close things for modification. For example, if something is called this way, it better not change in the future, because otherwise some person's code in production is going to fail. So we have this also responsibility to try to build things in a way that we can extend, but not modify. Thirdly, I'd say this is one we learned on the way. Of course, when we start to build something, there's so many different ways to do it, ideas, discussions, but I found it to be key that we avoid premature optimization. So we try to focus on specific business cases that the teams are undergoing and fix it for that specific case, and then make the exercise of generalizing it in a way that could be reused by all the teams. So that also means we start the first iteration in a slightly simpler way, and we might avoid abstractions at first. And maybe in a few months, when we get a second case that is similar, we might add some abstraction on top. Fourth, don't repeat yourself. So that's, again, very similar to the first one. It's important when we write a code that does something, that will be the source of truth of that. We don't need to repeat the same function multiple times. Fifth, small and iterative development. So that goes with our ways of working agile. Throughout the process, we had some Kanban boards. We are usually trying to pick up small parts of things. And we also try to focus on being consistent with updates and avoid some of big bangs type of updates. It's important to do something small, get feedback from users, and then adapt. And lastly, but not least, so we also want to be Falck specific, meaning that if some other company would be using this, of course, it could be adapted, but it would be difficult because this is leveraging all the great work by our DevOps team. And that's okay because it is Falck specific. However, it's solution agnostic. So for example, if some new solution in our LATAM business in Colombia is working with it, they will have their own data lakes with different storage account names. And all of this stuff is the solution's responsibility to manage these configurations. We help provide the interfaces for you to plug in the configuration, and then the things will work. Now let's talk about abstractions and design of modules, functions, classes. So looking back at the code, I think we are able to classify them as these 4 degrees of abstraction. And so let's start from the bottom. So we have what we call in the bottom base classes and methods. And this is, for example, a simple function. That's it. One simple function, one individual responsibility. We prioritize making it simple for unit testing, simple for maintainability, readability. And we have a lot of modules and classes around this design. If we go one layer up, we have what we call more of a simple class approach. So here we might already be combining some of these base models. We already use a lot of static methods, for example. Some examples of this would be some utilities or some string cleaning utilities that actually are using some other utilities as dependencies. So the change here is they introduce already some dependencies on other modules. If we go one level up, we get to a level 3 called, we call it advanced stateful classes. So by stateful, it means we're talking now about a class that has state. We need to construct it. It has init parameters. And it's also focusing on a specific workflow, a specific pattern we recognize from looking at all the teams, and we want to already implement this workflow in this class. So an example of this could be combining different building blocks from utilities, from static classes, to, for example, write a table to a data lake or create an ADLS or a data lake file blob So this already has a state. And here we try to find a balance between balancing the simplification to the user, but also the complexity behind. And that brings us to our fourth level. And this comes to a point where we have a very specific workflow that is very common across Falck. And again, we have these examples of just writing a table to data lake with a specific settings. And in the background, it maybe is using some class to do this, some class to instantiate a file blob, some class to manage some temporary files, if it's a Parquet file that we want to aggregate into one partition, for example. All of that complexity is wrapped around. The end user, the data engineer working on it will not see it, because all of that is managed inside as a step-by-step. Just like Lego blocks, it's happening in the background. And the goal here is to make it as easy for the end user, the data engineer working on it, that he can, out of the box, just create this Parquet file and put it in the data lake. That's it, following our formats, our configurations. And this one here is basically us trying to make a brief diagram of how our modules fit into these four levels. So you can see at the bottom, we have our utilities. So of course, these utilities are used everywhere around our code base. So they are quite foundational. Then we have our Unity catalog, which is also utilities, but about working within our Unity catalog metadata system. We have common, which is about some enums, some, for example, common default column names. When we have a metadata of a column, like a row hash or stuff like that, all of that comes from common. It's our source of truth for metadata-based stuff. Transformations, for example, it's just like I was mentioning, individual functions that just have single responsibility, same as validation. And as we go one layer up, and I can give an example on the transform data frame builder and data frame validator. So these already are focusing on a specific workflow, which is, for example, building a data frame. To do that, we need transformations from the other module. And we also focus on a specific step-by-step recipe to generate a specific type of data frame. So then if you take this example and imagine you are working on a star schema model, we want to make a dimension, you can use a data frame builder to run a specific set recipe of transformations that in the end you can use together with the validation and the data frame validator to build the dimension table. And that is our level above that we see there, called the table. So the table is a class that can be of different types, for example, a dim table. And lastly, we have what we call the simple end user functions. And currently we have two examples. So for storage, very simple functions, and extract. So off to you, Hubert, talk a little bit about our distribution in DevOps.
Okay, so let's talk a little bit about our DevOps setup. So firstly, why you should even care about something like CI/CD or DevOps in a project like this. So I believe that in the long term, it will reduce the number of bugs that you put to your code. It will reduce the wrong code in your production, and it will reduce the cognitive load that is needed to introduce new changes or new features. So we are trying to automate as many processes as we can, and also introduce a lot of software that tests your code quality, like linting, testing, or Sonar Cloud software. For users, it will mean that they get for users, it will mean that they will get a tested and reliable framework. There is no downtime when we deploy new stuff. As well, there is a possibility to stay with their own custom version or the previous version if there is something that they still have to use. Let's have a look at our build pipeline that we use during development. So firstly, it runs on an Azure agent. So firstly, we have to install all the dependencies. We have a Poetry configuration file for this. So all the dependencies are set there. Then we run Python on that. So the simple static code analysis tool. Then we run PyTest. So all the unit tests that we created for our code. Then there is SonarQube, which is a more sophisticated code analysis tool that will also help us to improve this code quality. Then we try to build our package to see if the newly introduced changes build correctly or not. Additionally, if we are running from the main branch, it means that the version is ready and we are pushing this artifact to our artifact directory. So the development process would look more or less like this. We work on our feature branch, and whenever your feature is ready and you want to push it to the release branch, you open a PR. It has to be reviewed and approved, but also the build validation runs. So even if you don't run it by yourself on your local environment, it will be run for you. You don't have to think about this kind of stuff. Of course, if it fails, you have to fix something in your code, but you will get an error message of what is wrong, which test failed, or what code needs to be fixed. Then all the different features that we have on the release branch, we gather and review these changes once again, and then we open a PR to main when the build validation is triggered one more time to make sure that there is nothing wrong with the code. As soon as it goes to the main branch, the build process is triggered once again, but then we are building the artifact and we push it to the artifact directory when we store all the version. This is available. We can download egg with pip install to our local environment from this artifact directory. The deployment is easier. It consists of these few steps. So firstly, we get the artifacts that were built previously. So our Python wheel, our Sphinx build, Sphinx, which is documentation hosted on a static website. We deploy to our dev Databricks environment when we run integration tests. So integration tests are more advanced than the unit tests. Here, we run it on a Spark Databricks cluster. Often it reads or writes to the Azure Data Lake, and basically at this point it should succeed because you should test it earlier, but just in case, just to make sure that everything works as it should. And if it works good, we can deploy to other environments and also update our Sphinx documentation page.
Thanks, Hubert. And so now it's time for the demo. So we have two little things to show. So firstly, I will share our implementation of the slow changing dimensions. If you're familiar with that, I will share my screen. If you're familiar with data engineering, it's a super common method for handling historical data and storing historical data of your table. So first of all, let me show you here. I'm now on Databricks. I'm on my cluster, and you can see, first of all, egg is already installed. And this is from the deployment that Hubert was talking about. So that's step number one. That's great. My cluster is also running. So let me go over here. So here I'm on my repository for egg. And first of all, we have what we call quick start examples. So this has been also our approach of making it easy for the team to adopt egg. We put a lot of example code for how to do a specific task on it. So it's very easy for people to onboard and see how it works. Here is a very simple example on the transform module about data frame builder. If you're data modeling, very commonly you need a date table. So why not have one out of the box? Tell us the dates you want and you have it. So it's a very simple example, but let's now move on to the slow changing dimension. So don't worry, if you're not familiar with it, I will give a brief explanation on how it works. And let's do a simulation. So we have, imagine an initial data load that looks like this. So we have 3 users, Alice, Bob, and Charlie, and we store this initial load. Then we have a new update, which is this one here on the top. Alice is also in the update, but you can see there are no real changes. So her age is the same. Bob has actually a change. He had his birthday, and now he's 46 years old. So you see, his age is now different. Additionally, we have a new friend, Piotr, which I Googled, it's the most common name in Poland. And he's joining as a new user. So we need to handle all these changes and track the history. So let's run this function and let's go down. And here I can display what the data frames look like, so you can see the tables. So these would be the first update and the second update. And now let's look at how egg is working. So for demo purposes, we have reset the table here so that when we run this, it will run the first iteration. So first of all, we'll just do a check to make sure this table exists. And if it doesn't exist, meaning that we are running it the first time, we're going to instantiate our class with the data frame for the first update, specify the primary keys of the table, what is the timestamp column, and then we can run the init delta and then write it to the data lake. So let's run it the first time. And now we can see it's initializing. Okay, now it's completed, and there it is. So first of all, you'll notice it's computed a few metadata columns. We have a row hash to identify the uniqueness of the row. And we have our classical valid from, valid to, as well as the is current true or false Boolean. So this tells us this is the latest row we have for this ID, number 1. And now, if you remember number 2, we have Bob's birthday, and we have a new user, Piotr. So let's see, let's run it the second time. And now you see it's going to be merging the new updates. So let's give it a second here. And of course, here I specified just a different table for demo purposes. And there we are. So Alice, no changes. So same as usual. But let's look at Bob. So now we have 2 rows for Bob because we want to track history on Bob's data over time. And we can see he was 45 years old from this date to this date, and now he's 46. And now this is the latest row. This one is false. So it's no longer the current row. Also, we see our new friend Piotr is now in the data. So this shows the very simple example on how this works. And to show a little bit on the code, so we have our classes here. We have a CD2 base. We have a validator to help with some validations. And to give a little bit just of the structure, so we don't go too much into the details, but we have a few private functions to help with, for example, creating the update set, meaning when we update something, we specify how we want to do it in Spark. We have data frame preparation, delta table operations, and then we have the public interface that you saw, init delta. So this is actually just validating and returning the prepared data frame with the metadata columns. And then we have merge delta. And this one will, for example, look into inserting existing records. And then it will handle the schema evolution in case there are some new columns coming. It's going to update existing records. So the ones that are true will become false if there's a new one coming. And then it's going to insert new rows, for example, Piotr. And of course, if there's an error, because thanks to Delta Table Framework, which you build on top, we can roll back and restore to the previous version here. So that is an example on that. And now over to the next demo. So now, Hubert, you'll share a little bit of our DevOps workflow in action.
Yeah, so I will show you what we what I was talking about previously. So let's suppose I just committed this fantastic try except block to our code. At the first glance, it may look okay. There is, yeah, of course, you don't want to put a try except pass to your code. However, this will execute correctly. There is nothing really wrong. However, if you try to see this in the IDE, you will already see that something is wrong. So, for example, it shows me that there are some trailing white spaces, which are not super dangerous, but maybe annoying at some points. This is more wrong because it says that you are catching too general exception. So you don't want. Usually, you want to look for a specific exception. You want to think about how this code may fail and put a more specific exception like value error. So this is how you would fix that. Then you run the formatter on this to make sure that these trailing white spaces are removed from the code. So you don't have to always think about that things by yourself because it will be tested for you in this build pipeline. So as you see, the PR that I opened with this exception block failed.
We cannot see.
Oh,
just a second. We need to share a different screen for the PR. Just a second here. Give us a minute, please.
Demoing.
All right. So I can also talk a little bit about that. So basically the examples that Hubert was showing is that first of all, we are working a lot more on IDE, and there we can catch a lot of these mistakes with the linters, with IDE. And next, it's about when we do a pull request. So when we are creating pull requests to our release branch, for example, which Hubert will now getting ready to share, we also want to automate a lot of these tasks about code quality. So Hubert, you're live, take it away.
Yeah. So it failed with exactly these messages that your IDE was showing you here. And now there is yet another thing, because some code may look correctly at the first glance, and also there is no issues with them with the piling. However, you may write a code that is highly complicated like this. So there is this simple function that I wrote to classify triangles. However, it might be not that easy to comprehend. So if you try to figure out what it does, it will be hard. Here is another example of a simple mistake that is not being caught. The code will execute correctly. However, the function says that it returns a string while it returns a boolean in reality. And this kind of stuff can be cast with the Sonar Cloud. So the comments are being put here. So the triangle function is too complex. It says that there is too many if-else blocks than allowed. Of course, we won't listen to that in every case, but we can just ignore that. But in this case, it would be wise to simplify this function a bit. Also here, it will say that something is wrong with the type hints here. The last thing would be the Sphinx documentation that we deploy to our static web page. So we try to put the correct documentation in a Sphinx format to most of our functions. So if you go to any of the functions, you will see that the documentation is here. It's quite verbose. If you wonder how it looks in the code, it's just something like this. So, for example, you have to specify the arguments. If you want to put some additional note, you put it like this. Then it's accessible through our VPN on this page. It's being hosted on the Azure Storage account. So that's it from the DevOps part.
Thanks, Hubert. And it's really a really important part to help us to automate our code and automate our ways of working and these quality checks. So now, if we can go back to the presentation, we have just a few last slides, and in just 5 minutes, I would just like to go a little bit over our results, challenges, and reflections. So first of all, I can see now, after 1 year, when I look in our DevOps, we have had like over 350 files that are importing our egg. So it's quite cool to see that over 23 different repos across different teams, or in fact, all of our 8 data teams are now using it. So it's been really, really great to see some of this adoption. And also, it's been interesting to see the way people use it, because when you build something, it's common that people use it in the way you don't expect. And that also means if we analyze here how people are using it in terms of different modules, it's cool to see first of all, the utilities that are the baseline for a lot of things, which is really nice. Also, we can see that the storage and the ADLS are really highly used. For the rest, it also makes sense. For example, common, it's not so used. It's mostly a knowledge-based used to feed all of the other ones. But quite cool to see. And now, if we can add a few words to the challenges, we've had a lot of challenges over the year. Here is, for example, an example. This was maybe 3 months into us starting to build it, 3-4 months. And by then, we already had the first breaking of our rule of the open-close principle. And you can see we had the deprecation. And it can be something as simple as a name of an argument in a function that is not so consistent with the others. And so then we deprecate it, and we automatically fix it to the correct one in this case. But it's been a challenging in reality to when you build something to have this future look and to try to predict and make architectural designs to understand how this can scale. So that's been one of the challenges and something we'll be looking to improve going on next year. Another one has been our setup on deployment and the whole adoption for our LATAM team. So one part is that LATAM team is a new team, so we've had to set up their whole environment there from scratch. There's been a lot of onboarding work, infrastructure, but now they have quite a very similar setup to us, all with Terraform, Databricks, all of that. But this was also at the same time we were starting with Egg. So that meant we had a very early version of Egg, and also the automation part was not working yet. So we had a lot of this manual transfer of knowledge, manual sharing of Egg and of the resources on how it works. So this is also something that has been one of the challenge points for us this year. And if we talk about reflections, I would, when we are talking about it, we summarized it into these 5 points. So first of all, looking back over this last year, it's been a really, really amazing, first of all, to be part of this team and this community. It's super cool to come to work and be working with these other engineers and talking about how do we improve ideas for how to build this feature and how to do it better. So having this continuous improvement mentality and people who are really wanting to learn and wanting to do more. It's been great to be around this community. Secondly, we've also learned that adoption is critical. So we've been spending and investing a lot of time, a lot of resources to documentation, as you saw through the Sphinx documentation we have, with the example notebooks that we already shared a few examples on that. And also, and more recently, we've been learning about it, but involving the users when we are developing the feature, just involving them from the start, it's also been super important and something we will try to do more and more as we progress next year. That brings us to number 3, that user feedback is key. So we need to always continue to avoid blind spots and make sure we are seeing the usage, how the real usage is. Fourth, about reliability. So very important to invest on unit tests, integration tests, because these will be deployed to all clusters for all data engineers. So we have a big responsibility to make sure the code will not break. The code is reliable. And fifth, looking back, I think we have quite initial exciting results for the first year. We see all of the teams are using it, some in a more advanced way, others are still just starting to use it, for example, LATAM. But overall, I think overall the whole team is quite happy. And I also want to thank everyone in the data engineering community who has been engaging with it, trying it out, giving feedback, and also, of course, to the ACT team for all the work and all the cool ideas and implementations we did. So thanks, everyone. And now it's time for our Q&A. And of course, we have a contest going. If you're into Python, machine learning, you want to give it a shot, go ahead and try it. It's a machine learning forecasting challenge. We have very great prizes. Okay, so we have question number 1. What are the main advantages of using PySpark in NEG, particularly in terms of performance and scalability? Good question. Do you want to start this one, Hubert?
Yeah, I guess that PySpark is scalable by nature. So it's also quite really to comprehend by people. You can switch between Python and SQL. So I would say that's the first pick if you work with Python and the Databricks.
Yeah, I would also add that working in a cloud environment, it helps you bring this scalability. So if you have a pipeline that you need to make sure it runs in 10 minutes, you can always scale it up, the compute or the memory, or you actually have a lot of flexibility in that. And you can really run it faster if you want. So this is useful for near real-time projects if you want to make it super fast. Or if you just have very large workloads, you can distribute it. So for big data, it's really great. If you're working locally, of course, Python, Pandas is more than enough. But as you grow and you want to scale, then PySpark really brings that. And so it's natural for us to then, when we build Egg, we build on top of PySpark because it's the core of working in Databricks. So I hope I answered your question. So any more questions? All right, we have a new one. So question 2, could you explain how Egg handles data transformations and validations in terms of standardization and automation? Okay, so our first approach was to englobate this type of workflows like transformations, validations in what we call the transform module. Meaning it's about when we are working the data lake, we want to convert from the raw layer to the clean layer or the curated layer. And the way we organize it is, so if you look back at if you remember our dependencies diagram, at the bottom we have firstly individual functions for transformations and validations. A simple example is given this column name, hash it so that it becomes a hash value instead. Or it could be replace nulls in this column. So we have individual transformation functions for it. And then we have similar approach for validation. Validate, this column cannot have nulls. Validate, this column must be between this and that. So we have, first of all, these building blocks. Next, from this, once we have established this foundation, we built what we called is data frame builders or data frame validators. And there we also have different variations. So by having abstract classes, and then we inherit. So for example, we have a specific workflow, and talking about standardization. Back in April, we were working a lot on enterprise and standard data models. And to do that, we agreed on a few naming conventions, a few standards for the name of the columns, for the granularity of the tables, and for stuff like that. And so we actually encompassed the transformations and validations into what we call the data frame builder, which we then have a variation called the standard data frame builder. And that one is responsible for building this specific type of data frames. And it will know which metadata columns to add, how to name specific columns, for example, primary keys. And we have a similar standard data frame validator that is responsible for doing this validation specifically for this standard table workflow. And then if you have these two components, data frame validator and builder, we then want to also put them together and wrap it around what we call a table object. And the table object, we also can inherit and have different variations. In this case, a standard table object. And it's in fact just wrapping this complexity of doing a build, doing a validation, all in one class, so that users can easily instantiate the standard table object with some initial data frame and run build function, and then it will automatically validate and output the desired format you want. So after you can save it to the Delta Lake or whatever you need to do with it. So that has basically been our philosophy. We try to start with some components, Lego blocks, and build our way up to help them deliver at the end more business-oriented workflows. So in our case, talking about standard tables, but the idea is the same for other tables. So for example, fact tables, dimension tables, what I showed you in the demo, a date table, something as simple as that also runs on this flow.
So recently we also introduced a small module that allows you to run your own validations. So if you have validations that are specific to your data, some kind of counts or very specific checks, there is a function signature that you should implement. It should return a specific type of object, whether the validation succeeds or not. And there is a machine that will go through all the functions that you defined, and it will run it, and it will return you some results. So it's allow you to make this just a little bit faster.
Yeah. All right, question 3. Any plans to further develop Egg, perhaps integrating new functionalities or expanding to additional use cases beyond those it currently supports? Yes, so it's only been a year, and we've tried to focus a little bit more on basic initial stuff, but for sure there is room to grow. I think the way we try to plan the next steps is, first of all, look at what the teams are working on. So if we have a lot of projects coming next quarter about data modeling, we will try to also build features to help people data model stuff. So this can be these fact tables, for example, or something along those lines. Or if it's more about ingesting new data, maybe we can focus on building some features around that to help people in the extraction workflows. So that's been our approach. One point we also want to expand, for example, is these integrations with, we have currently one for SharePoint clients. We want to add for Power BI. So we can easily automate from Python, Databricks, the refreshing of Power BI data models, for example. So there's a lot of good cases there. But we need to focus on what are the business priorities and support that as the top priority and as a way of figuring out what do we need to do, as well as user feedback, of course. All right, so that's all the questions. Thank you all very much for listening in. And you have here the contest QR code. Check it out if you like machine learning and you like Python. It'll be fun. Thank you, everyone.
Thank you. See you.